Welcome at NOFFZ. My name is Markus Solbach. Today I want to talk about telematics and infotainment test. Automotive communication trends have been rapidly changing over the past years, increasing requirements to telematics control units, intelligent antenna modules and other connectivity and infotainment devices. Nowadays, unidirectional communication is still present in the form of radio and GNSS, but bidirectional communication has established itself as standard. Modern vehicles need to provide cellular communication, data up and download, and even wireless LAN to realize customer expectations, as well as safety functions such as eCall and V2X. This additional bidirectional communication requirement leads to an increased complexity in TCUs inside the vehicle. The channel count for antennas on modern TCUs can easily reach 10+ RF interfaces. So software and hardware testing grows exponentially more complex with each additional RF interface and their interdependencies. Today's vehicle need to operate for 15+ years and guarantee at least 300,000 km reliability. This includes all of the communication devices. So the Volkswagen 80,000 norm, for example, defines the test necessary for TCUs, typically beginning with a parameter at 0 km, followed by a monitoring test for the life cycle strain and a final parameter test after the life cycle strain of 300,000 km again. So NOFFZ has developed tools to provide flexible and future-proof solutions for parameter and monitoring tests, which are frequently used in production test setups as well. A very good example are the non-signaling testing requirements for parameter testing. So please take a look into the following video.
Hello, my name is Kaiser from NOFFZ Technologies. In this video, I would like to introduce the Universal Wireless Tester. NOFFZ and National Instruments partnered to create a truly flexible RF instrument for testing wireless communication devices such as automotive infotainment systems, eCall modules, smart antennas, Wi-Fi routers and Bluetooth dongles, smartphones and many more. We are adopting testing needs for everything that goes wireless, from self-driving vehicles through smart homes to the industrial Internet of Things. Let's take a closer look. As new wireless technologies such as 5G New Radio, wireless LAN, 802.11ax or Bluetooth Low Energy are increasingly used across multiple industries, test strategies need to be adjusted. There is a demand from the world of IoT devices for high channel count test solutions. On the other hand, there is the need to employ the latest technology to support self-driving vehicles with 5G radios and car-to-car communication interfaces. The essence of these requirements is flexibility, scalability, and long-term support. Our concept separates the transceiver side of the system from the RF front end, slightly changing the way of thinking when engineers select RF measurement instrumentation. On the front-end side, we always need to think about how many antenna ports will require any type of RF measurements. For example, if the client wants to test smartphones, we need to consider at least 2 ports for cellular link, another 2 ports for wireless LAN, plus GNSS, Bluetooth, NFC, and maybe even FM radio. So we can easily end up in the range of 8 ports on a single device, with a growing tendency. In a typical manufacturing test setup, it's common to design test fixtures for 4 devices tested in parallel, summing up to 32 ports. So, how about the transceiver side? How many real analyzers and generators can we add to the system? That is the cost driving factor, influencing test time, yet in most of the cases we cannot decide. We buy instruments where the number of transceivers is strictly tied to the number of RF ports. This is where the UWT wants to break the habit. We allow to configure the RF port count independently from the transceiver count. The system is designed in a way to add and remove transceivers from the test rack like we're upgrading PCs with memory modules. If someone needs higher throughput, in other words, better test time, it is easy to add an extra analyzer and generator to the system. The system will automatically detect and use any new analyzers. The way of operation is similar to a typical client-server architecture. Measurement requests on a given RF port are the clients. The analyzers and generators in the background are the servers. The measurement and playback requests are arriving to the server at any time, and the server starts looking for an available analyzer or generator to match it to the request. With this approach, we can add new transceivers to our server to decrease test time, simply by empowering our RF instrument with extra resources. If the transceiver is not occupied all the time, we can decide to take it out of the test station and use it in another test cell which requires higher throughput. One can build test systems in many possible combinations of RF ports and transceivers, from a simple, focused one-to-one setup to a high-throughput 8-to-64 arrangement and beyond. This is our approach to building a universal test platform for wireless test challenges of today and tomorrow. We're very happy to discuss your requirements and ideas how to configure a UWT for your project.
Okay, the UWT can be used for test cases ranging from cellular over wireless LAN to Bluetooth and other wireless communications such as V2X. This broad spectrum in testing non-signaling connectivity technologies combined with its modularity and flexibility built a basis for the UWT's great performance for parameter testing. Monitoring tests typically require a signaling instrument on protocol level that can cover long-term call and download tests, emergency call tests, application-level tests and others. So these are optimized for real-life simulation testing to monitor all functional parameters in signaling mode conditions under life cycle strain in climate chamber or shaker setups. These test scenarios often require testing multiple participants and interactions between these DUTs and the test instruments in parallel. Parameter testing instruments were often also used for monitoring test cases. However, these instruments are over-specified and increase the cost of tests significantly, especially due to the parallel testing of multiple DUTs. Realizing that there is a need for a competitive multi-DUT signaling test for functional and system testing. So NOFFZ developed the base station emulator to answer these requirements.
In this video, I would like to introduce the NOFFZ base station emulator. In essence, this tool can bring a cellular network to the workbench to make wireless device testing easier than ever, from a legacy GSM coverage to the latest 5G capable towers into the lab. Sounds interesting? So let's take a closer look. Validating cellular devices like automotive telematic control units, new generation vehicle-to-vehicle communication modules, smartphones or IoT cellular interfaces require recreating complex RF testing scenarios on your workbench. The NOFFZ base station emulator makes this possible by creating a custom cellular network to serve these testing and characterization needs. Using high-power, real-time computing and software-defined radio, you can create custom mobile networks for testing in a compact and cost-effective way. As a result, users of the base station emulator do not need to go out to conduct field testing, relying on static, uncontrollable consumer cells. They neither need to invest into complete, heavy, high-cost instrumentation to verify every single paragraph of the 3 GPP specifications. With this emulator, they can configure a couple of different cells and attach multiple phones in parallel to a well-defined test network to see how the tested modems will behave in the real world. Among many test cases, you can start with checking how the DUTs can register and go through the authentication procedures when attaching to the test network. Once the tested devices are connected, you can initiate phone calls, send and receive text messages, exercise handovers, call the emergency numbers, and monitor high-level parameters of the call status, such as signal-to-noise ratio, bit error rate, transmit power, RSSI, or the presence of the proper logical channels. Reaching out for data services, an IP address will be allocated to the device under test, which enables us to exercise download and upload testing in order to verify the data throughput capabilities of our phone modules, with different modulation schemes and MIMO modes. Moreover, the base station emulator can act as a network router for cellular devices. Our application focuses on verifying phone module functionality over longer periods of time, where test time is not anymore in the range of minutes, but in days. So our clear target has been to enable testing several devices in parallel and monitor their performance under extreme conditions and extensive usage. Our systems are designed to interface with 8 dual SIM modems, so they will appear as 16 individual phones in the NOFFZ cellular network. With the latest generation of devices, we are approaching 100 RF connectors on a rack. Yet we can exercise power levels on different antenna ports precisely, try out different MIMO modes, and simulate antenna failure scenarios. We extend our systems with GNSS signal simulation, wireless LAN hotspots, Bluetooth modules, or even radio broadcasting to recreate the dense population of radio waves in today's ether to the lab. This is our approach to make sure that the phone module will be on the internet 24/7, or that the car can still make an emergency call or stay connected in the next generation of transportation, even after 15 years of usage. We are very happy to discuss your requirements and ideas how to bring the most out of this technology.
Yeah, NOFFZ technology has leveraged its UTP test platform and products like base station and universal wireless tester to support customers in testing their connectivity and infotainment devices efficiently and with a competitive pricing. These modular and scalable tools have been integrated in validation testers such as the UTP 7033 and production testers such as the UTP 9011 at several customers. On the other hand, the base station and UWT have also been deployed directly to customers to solve specific testing requirements in production and validation. So thank you for your interest in our telematics testing solutions. Please reach out to us at noffz.com. Stay healthy.